Have you ever wondered what might exist beyond the observable universe? What if I told you that there's a mirror image to everything we know? A parallel existence, not of dark, but of antimatter. It's as if nature, in her infinite complexity, decided to create a twin for every particle we know. These twins, called antiparticles, are identical in every way to their matter counterparts, but bear the opposite charge. Imagine a world where positive becomes negative and negative becomes positive. It's a world where matter and antimatter, when they meet, do not shake hands and become friends. Instead, they annihilate each other, releasing an incredible amount of energy in the process. This idea might seem like a product of science fiction, but it is not. This mysterious opposite to matter was not just a figment of scientific imagination, but a reality discovered in the 20th century. The story of antimatter begins in the early 1930s, in the mind of a brilliant physicist named Paul Dirac. A mathematical prodigy, Dirac was obsessed with the elegance of the universe's laws. He was convinced that these laws must be beautiful and simple, and it was this conviction that led him to a startling prediction. Dirac's equations, designed to reconcile quantum mechanics and special relativity, suggested that for every particle in our universe, there should exist an identical twin, but with an opposite charge. This meant that for the negatively charged electron, there should be a positively charged counterpart. This hypothetical particle became known as the positron, marking the first theoretical discovery of antimatter. In 1932, just a few years later, Carl Anderson, an experimental physicist, detected a particle in cosmic rays that behaved exactly as Dirac's positron. Anderson's discovery confirmed Dirac's prediction, and the existence of antimatter was established. Dirac's bold prediction and Anderson's discovery opened the doors to a new realm of physics. So we've uncovered the existence of antimatter, but what does this mean for us? What can we do with this knowledge? Well, let's delve into the potential applications of antimatter. Already we're seeing its use in medical imaging with positron emission tomography, or PET scans, which harness the power of positrons, the antimatter counterpart to electrons. Now consider the energy potential. Just a grain of antimatter holds the energy equivalent of an atomic bomb. Imagine if we could safely harness and control this power, the energy crisis could become a thing of the past. But there's a catch. Antimatter has a tendency to annihilate when it comes into contact with matter, making it incredibly challenging to store. Yet just like the explorers of old, we're not deterred by challenges, we're intrigued by them. Antimatter, a mirror image of our world, holds immense potential. As we venture further into the universe, who knows what possibilities we might uncover. Until then, thank you for watching, and never stop being curious.